So, rare metals are not these fancy things that rich women wear in their jewelry, rhodium coated earrings or whatever. We get them even in your normal household. So I was surprised to see that some electric toothbrushes contain up to 35 different metals. I was tempted to go and take mine apart at home, but my husband stopped me. But they say 35 different types of metals, and these are small little components. And then, of course, your iPhone contains about half the elements found on Earth. So we're pretty special. I think all the other cell phones as well, not just iPhone. But you can say, I've got half of the Earth in my phone, maybe. So I think a lot of people do not or underestimate how much metals they have in the appliances at home, even though the casing on the outside is plastic. There's more to it. So the uses, platinum, mainly still catalytic converters, computer parts, oil refining, and jewelry. This is current uses. Palladium, similar to platinum, is just a bit cheaper. Also catalytic converters, electronics, medical needs. There's some research going on that palladium isotopes can be used for treating certain types of cancers. I'm not sure if that is true. Maybe some people else can. I was not aware of that. And then also jewelry. Rhodium, also used, quite unique metal. I follow the rhodium price. It's more expensive than gold, so it interests me. So used in glass making, finishes of mirrors and jewelry, electrical connectors, aircraft turbine engines, and then 82% of the world rhodium supply come from South Africa, which I think, you know, we're not that bad. I knew nothing about these metals, and as I was going along, I was saying, I'm actually impressed. And yeah, I thought we were just exporting iron ore, but we do have other metals as well. So I think that is quite impressive. So this is a summary slide that I stole from somebody on SlideShare, I suppose. That's where I get most of my information. And all it does is just summarize the platinum, palladium, iridium, rhodium, and ruthenium, and their current uses, where they are used, and the markets. So I'm not going to read through that. It looked like a pretty picture to put in. Okay, so those are the current technologies. I've told you what I see as a rare metal, and you're more than welcome to disagree. Mention some little bit of economics about it. Now, the emerging technology trends. This is what we want to know. So where's the world going? What is going on? So basically, there are 4 emerging technologies that I think we all can agree on. There was lists and lists of 20 and even more. Firstly, autonomous things. They call it autonomous things, and I like that because I also call things thingies and so on. So these are your robots, your drones, your autonomous vehicles, and all of that using artificial intelligence. Then there's empowered edge. This uses endpoint devices such as your phone, as well as devices embedded around us. So this makes sure you're always in contact with yourself, with your home, switching on your fridge, your oven, etc. Okay. Then also your smart spaces, very similar to that. As it's an environment in which humans and technology-enabled systems interact in increasingly open, connected, coordinated, and intelligent ecosystems. So even in your workplace, you're going to go to smart spaces. We don't have to sit in the office. I can sit in the tree, you can sit under the tree, and somebody can sit in the office, and we can connect. And then also quantum computing. Quantum computing being one of the very powerful new emerging technologies. And here they use subatomic particles as the quantum state, and information, the sharing of information is so much faster. So all of these things you can see is much orientated towards electronics. So things are getting smaller, things are getting more intricate and more complicated. It's not just a normal diesel-powered engine, as I can say. It's much smaller than that. Then the new manufacturing technologies, one of them is additive manufacturing. So additive manufacturing of your polymers have been around for many, many years. Metal additive manufacturing gaining very, very quick momentum these days. South Africa also getting on the bandwagon to become a global player, although there is still some challenges and initial investment cost. Then there's things called collaborative robots, or as they're also known, cobots. This is actually where you work alongside a robot. And they are in your workspace. We're not there yet. Maybe one of these days. And then there's smart manufacturing. And this is also to do with robotics programming, where you can change manufacturing systems through the internet anywhere in the world. I was at the NARCAM show last week in Durban, the automotive show, and they had augmented reality glasses, and they had assisted reality glasses and all sorts of things, and you can change your manufacturing technique, and the computer speaks to you if you're the operator and doing something wrong. It also measures your ergonomics. As soon as you start to hurt your back, it tells you, it warns you, you're now straining yourself. So things are getting much, much smarter as we go along. So what are the challenges? First thing you can think, if everything is going computerized, cybersecurity. And yeah, some people are closing down cybersecurity sections. They say it's of no use, the research, but it is very important, especially for manufacturing companies. If your machine is using some or other programming language, I can hack your computer and I can get your programming language and I can get all of your information, your process information. So that is a huge risk. So cybersecurity, that needs to be addressed, and I'm afraid a lot of SMMEs is not even aware that cybersecurity is a real threat to them, because they are just entering the market. They're buying their first machines, their first PCs, so they're not even aware of the risk. And then the workforce development. So you know you will need different workforce working with these intelligent systems than you did before. So upskilling, very important. And I think South Africa is in that space. Everybody's talking about the fourth industrial revolution, but is the workforce ready to embrace this change? And what are the companies doing to make sure they are ready to adapt to the technology? We are lucky in terms that I think most people in South Africa do have cell phones. Technology is not that big a burden. You think people are stupid, they're not. They have their cell phones, and if they can operate Google and Facebook and WhatsApp and Telegram and what else there is, they can function very intelligently with the manufacturing systems, just as long as the interface is familiar. That's all, just a familiar interface. Okay, so those are the challenges. Then I got a study that was done by the Fraunhofer Institute in Germany. It was commissioned by the German Mineral Resource Agency, which I found very interesting. I think it's 2016 or 2017 study. They did it because they want to know about the demand and development in mineral raw materials in order to better estimate possible long-term price and supply risks. So as we know, Germany is not a country that has mines. I don't really know what they have, except bread and cheese. Okay, so they've got coal. So they are very dependent on metal imports. So they need to know their risk. And if there's one thing about a German, you know, they think like 5, 10, 15 years ahead, because they need to make sure that everything is in order, very precise. So in particular, what they did is they looked at key and emerging technologies that are resource intensive or resource sensitive and can trigger strong demand impulses and have a significant influence on commodity markets. So I thought, oh well, let's see what did these Germans get to. And I was quite surprised. So they've identified these 16 metals on the left-hand side, and then they did a demand study and a production. So the demand is in 2013 and then 2035. So they're looking at up to 2035, and then the emerging technologies associated with it. So the metals are lithium, your heavy rare earths, rhenium, light rare earths, tantalum, scandium, cobalt, germanium, platinum, tin, palladium, indium, gallium, silver, copper, and titanium. So obviously I will show you now how they looked at certain technologies and what materials these technologies will use, and then they selected the metals. And then they gave it, so what is important here is that factor in 2035 So the higher the factor, the bigger demand will be. So you can see lithium ranks at number 1, and that is most probably due to the lithium-ion batteries, or lithium being used as another source of manufacture for other metals. All of these metals that is there on the left-hand side, you can also see many of them are being used in electronics, computers, catalytics, infrared technologies, etc. So you can look through the list, but I think this is a very nice summary what they did. Then also they looked at the global production of selected metals 1993 to 2013. So this is actual production volumes and also the compounded annual growth rate. So they've got the metal, the annual compounded annual growth rate, as well as a growth factor, which they calculated then from 1993 to 2013. And you will see they've got the normal metals, iron, aluminium, copper, titanium, etc., as part of the list as well, which is not on the first list, which is the new technologies. So from this list, you can see growth factor of indium 5.5, cobalt 5.2, and somehow in this growth factor table, you can sort of get to the importance, which of these metals can be important. In any way, for us as a country, which metals the Germans see is important, because they buy from us. Okay, so what can emphasis be put on? So this is just information sharing. Then the next thing they did was they took this technology analysis and they did market survey on it. So what they did is they took the technology stream, like the first one you will see, the emerging technology, automobile manufacturing, aerospace and transport, and then underneath it there is 7 technologies that is going to emerge or is emerging. They grouped the chemical elements, and then they looked at the status of the technology in 2013, the predicted mark in 2035, the resource demand in 2035, and then the recycling potential for 2035. So you can see the subcategories there as well. Say we take number 1, lightweight steel construction with tailored blanks, which is for automotive. Chemical elements or the metals, aluminium, magnesium, titanium. It's developed technology. They've marked it with a tick. We know it's developed. The market in 2035, will it be introduced, penetrated or saturated? They say the market will be saturated, saturation by 2035. Resource demand, non-critical, that's their feeling. It will be non-critical. There's enough supply of those metals. And then the recycling potential, yes. Okay, so even when I was still an academic in, I don't know, many years ago, the German automotive market, Volkswagen especially, they designed their cars for 95% recycling. You needed to prove you can recycle 95% of the materials in the automobile. Everything, from the seats to the cigarette lighter, etc. And they're even trying to move that up. I do think they did get government incentive for those designs, and if they complied, there was some sort of deal. Okay, so these tables, so you've seen there in red, what I've marked in the red little blocks on the screens. Those are just the metals and metal areas where I know South African universities or science councils are already doing research in. So if aluminium featured, I know there's a couple of universities as well as the CSIR doing aluminium research. Then fuel cells, yes, we know platinum, there's aluminium again. Alloys for lightweight airframes, again the aluminium alloys. So I know there are certain universities, so I've just very quickly looked at it and put red blocks in to show the presence of South African industries or universities or R&D taking place already. And I might have missed a couple. I mean, I don't know everybody and everything, although my husband would disagree. But so I've just highlighted some of the areas where I know South Africa is already playing a role. So we are not doing that bad at all. Actually, we in the manufacturing and alloy development, I think we're quite good. So from this table, I think it can be important for people working with minerals beneficiation to see which of these metals should be concentrated on in the next couple of years. So they've got, okay, so they look similar, but they're not the same. That's slide 28. So it covers automotive, or the transport industry, information and communications, which is the next one. Then energy, electrical and drive technologies. I'm not going to read through all of this, really. No, I will bore you to death. You are going to distribute this. And yeah, so this will be available for you to look at. I've also referenced it previously. And then slide 30, chemical processes, medical engineering, and also materials technology. So this is extensive list of emerging or technologies and where they will be in 2035. So I think it's not cast in stone for South Africa, but it will give us a guideline because they will base it on other global trends for sure. Okay, so this is the cheat way for me to quickly get to some sort of answer. And what I like about this is not just the rare metals. Yes, the rare metals are mentioned, platinum, palladium, they are mentioned, but also the normal metals like your coppers, your cobalts, your chromiums, that they are not that rare, but they are mentioned. They will still be important, play an important role. So this is the conclusions from their study. Okay, it's not my conclusions, this is their conclusions. They say the following measures may be considered to ensure the supply of raw materials to industry. So they've identified those metals that they deem critical. They say expansion and improved efficiency of ore mining or metal extraction. That we have already identified as well. So it's not new ways of mining, but improving the efficiency of what we're already doing. Substitutions at the level of materials and technologies. These are the design engineers, the electrical engineers. If you choose your material, see if there's substitutions, come up with something new. Maybe some physical metallurgist can design a fancy alloy. Then the resource efficiency in production and use. Recycling, ensured by recyclable designs, recirculation strategies, and efficient recycling technologies. And I think there the country is still lacking. Why am I saying that? Because I struggle to get rid of some of my old technologies and I don't know where to dump it. So I sit with a whole room full of very, very old technologies that I don't just want to throw in the heap because I know they're not biodegradable. Otherwise I must get a small crucible at home and just start melting them, I don't know, something to that effect. So I think more can be done in the country. I see now some places do have these recycle bins. I did see some at Macro, I see some at Builders Warehouse where you can throw away your batteries. So at least it is starting to take place. Okay, and then also when developing new technologies, now these are the researchers, existing options to ensure the supply of raw materials should be an integral part of the basic planning and considerations. You cannot just do a design thinking that all the materials in your design is going to be available forever. Okay? So it means that even at a tertiary level where we have our students, we will need to have some sort of shift in how things are approached. Then just to show you that I also looked and I saw a government, there is some national initiatives that has been ongoing for quite a couple of years that covers some of these things that are important, like the solar energy technology roadmap that exists. There's the advanced manufacturing technology roadmap. The additive manufacturing one, the titanium metal industry. We've got the aluminium roadmap. So we've got all of these roadmaps, and I'm not sure if these roadmaps talk to each other. I don't know. So I think there's maybe it's my ignorance. I apologize if I'm ignorant. I'm not sure if there's a lot of contact between of these initiatives because I think some of these things are well advanced. Maybe just not everybody knows about it. And there's many more. There's IEC, and I didn't even mention that. So what are the challenges facing the South African industry? Basically, we're import-driven, assembled goods and equipment sector. So what do? We export raw, we import, we assemble, and we export again. So we do not want to be known as an assembling country. We want to be innovative. We want to drive technology and innovation and sell our products, not just our raw materials. Global sourcing by OEMs dictate volume spread, and I must say automotive is guilty of this. They decide where you will buy from, who you will buy from. If Ford comes to me and I'm a manufacturer, they tell me, you will buy your wheels from China, I have to do it, I have to comply. I cannot go to a local supplier. So luckily the localization drive from government is very good in terms of automotive, that they have to localize. So maybe something in the other markets, something similar can be done. There's a lack of large product or equipment programs to drive development of advanced materials or advanced metals. Maybe more coordinated. I mean, we've got titanium here, we've got aluminium there, there's all of these bits and pieces, maybe something more coordinated. Then the length of the supply chain and the cost of doing business. Cost of doing business is sometimes a problem for people. Although I was at another show, can't remember, last year, and these foreigners were telling us, no, they like doing business with South Africa because we are sort of seen as politically impartial, because US and China has got some issues now, but everybody can do business with us. So China do business with us and US do business with us, but they're actually doing business with each other, but we're the middleman. So there is some advantages of being in South Africa. So maybe we must do international. Then the conservative nature of the local industry. Unfortunately, a lot of the manufacturing industries are extremely conservative, they will tell you. We've been doing this for 30 years like this. I cannot change now. Oh, it's the most difficult thing to get them to change or adopt a new technology, but they are coming around slowly. Then there's infrastructure inefficiencies and lack thereof. Unfortunately, a lot of the infrastructure in industry is quite old. They did not have foresight to plan, or maybe the price gap was too big. I don't know what happened. Then there's an increase in regulation of materials or metals environmental compatibility. So some people don't want to use certain metals because of restrictions, etc. But that is just because it's going to cost them maybe too much. Economic competitive issues. I'm not an economist. Reliant on imports to move further up the value chain. Lack of adequate skills and design capabilities. That comes out very strong on many forums. Materials and process qualification and testing to ensure quality. We have very, very few places that can actually give you independent testing and evaluation results. And then the implementation of Industry 4 paradigms. So we've heard about Industry 4 in the mining, but how do we implement this across all the various sectors? So how many people have been in industry lately, or a manufacturing company? Did you see any signs of Industry 4? Just one? You see, it's very largely still non-existent. Yes, we show it can be used on a mine, we can fly a drone here, but it is really not implemented, and I don't think a lot of industries have actually a plan of how to implement it. I don't think they have a plan, or maybe they don't know how to do it. So I'm ending up with a little bit of a SWOT analysis, because I didn't want to summarize anything. I think a SWOT analysis summarizes everything. So these are just my broad thoughts. It's not cast in stone. So the strengths. We in South Africa have the largest value-add metals market in Africa. Okay? Largest manufacturing and materials industry in Africa. Significant natural resources. So I think those are huge strengths. Weaknesses: protection of local value-add material providers, lack of large programs to drive materials RDI, research and innovation. There is disconnect between the RDI collaboration across the NSI. And also, I don't think everybody knows where they're supposed to play. CSIR is slightly out of link. Universities are playing where CSIR must be. Mintech is where that guy must be. So there's a little bit of disconnect, but we're all doing everything for the greater good. So that can, I suppose, be managed better. Conservative local industry leading to low local demand. Qualification and testing capabilities. This is in terms of design, materials testing, etc. Opportunities: water scarcity. So what I'm saying is an opportunity because of desalination, all sorts of other challenges. So we can have a huge technology drive in building that, developing that, and selling those technologies to places like Saudi Arabia. There must be other dry countries in there. So it is maybe a bad thing that we have a water scarcity, but it's also a big challenge and opportunity for us to corner a big market. There's very few countries in the world that is water secure. Okay, so that is an opportunity. Then environmental and waste concerns. More can be done on the waste management, recycling. Increasing cost of energy, it's an opportunity, because we need to say, how can we bring this down? How can we make it more efficient, more self-sustainable, that load shedding doesn't bother us so much? It does bother me. I'm supposed to bake a cake yesterday for an anniversary of a friend of mine, so now I have to bake that cake at high speed when I get home to deliver it tonight. Then we have an attractive export base, existing but limited expertise and capabilities. So there's lots of development that can take place. And then the regional market. I don't think a lot of industry in South Africa do business with just Botswana, Namibia, our closest regional markets. There is huge, huge potential. Those people are hungry for technology, for implementation, for manufacturing. And then threats, global competition, don't make a mistake. We're part of BRICS, but India, China, and Russia will sweep the floor with us if they can. Okay, because it's survival of the fittest. So global competition, huge risk or threat. Long export supply chain, so sometimes lots of red tape. Significant international RDI funding in advanced materials sector. So we are competing internationally. If you look at the research budgets of other countries, in very, very, very small, I mean, I did it for laser-based work. It's millions of euros. We don't even have 5 million rand set aside, and we compete directly. So what we achieve for the money or the funding we get is actually pretty amazing, if you think what they do. So we are competing in that arena. Then also uptake of new manufacturing technologies and paradigms like Industry 4. So now we develop friction stir hydropolar processing. Who's going to use it? So the industry is very slow of uptake of all these new techniques and metals and alloys. So our local industry is just a bit slow. And then international environmental controls. You know, sometimes Europe won't buy from you if you cannot prove that you comply to their regulations in terms of environmental issues and pollution and those sort of things. You need to certify that you can. So this SWOT analysis thingy is really my summary, conclusion, and recommendations all in one slide. Just because I was too lazy to do more. Okay, thank you. That is my talk. Those are just my thoughts of things that I've read through of the last couple of years at CSIR when we did some case studies. So I cannot answer. I can answer some questions if you really want to, but that will just be once again my opinion. But I can. I'm open for that. Thank you.